So this clustering that is coming under the unsupervised, the basic difference between the unsupervised and supervised machine learning. In case of supervised machine learning, that we have the input features as well as output. But in case of the unsupervised machine learning, we have only the input data. We don't have the output. So the point is, how do we classify the data points? So in the unsupervised machine learning, we classify the data point based on the similar pattern. So based on the similar pattern of the data point, that we will categorize the data point, that the one particular data point that will belong to class 1, that particular data point that belong to class 2 based on the similar pattern. So in the clustering algorithm, there are three types of the clustering. So the best example is that is the k-means clustering. So k-means clustering is the best example of partition based clustering. So this one, that is a partition based clustering or centroid based clustering. So on the basis of the partition based clustering, that is k-means, this one is the example. Second is the density based clustering. So density based clustering. So in this, the example or the algorithm is DB-scan. And third one, that is a hierarchical clustering. So today in this session that we will discuss this hierarchical clustering. So as per the definition, this hierarchical clustering is a method of cluster analysis that used in the data mining. That used in a data mining. So it seeks to build a hierarchy of cluster in a step-by-step manner. Okay. So there are two types of hierarchical clustering. So first is the agglomerative clustering. Okay, and this agglomerative that is coming under this hierarchical clustering. And second is that is a divisive method, divisive algorithm. So this agglomerative clustering that we call as the bottom top approach. Bottom top approach. Okay, or bottom up approach. And this divisive, that is a top down approach. Top down approach. So here in this session that we will discuss the agglomerative clustering. The reason behind this agglomerative, the importance of this agglomerative is, so first is that is the sklearn, that is a library in the machine learning. This agglomerative clustering approach, that is a by default. So whenever you use the sklearn, this library, so this agglomerative clustering, that is a by default. So you can use the divisive method also, but this one is a agglomerative, that is a by default clustering option. Okay, and one more difference, one more specialty of this agglomerative compared to this divisive that we will discuss later. So this agglomerative is, here let's say we have some data points. These are my data points. So we assume initially every data point as a cluster. So that is, you can say, that is the initial step. So initial step in the hierarchical agglomerative clustering. So start by treating each data point as a separate cluster. So this one is a one cluster. This is one cluster. This will be our next one cluster. Okay. So for example, let's say we have n data point. So n data points. So n individual cluster that we assume. That is in initial step. So start by treating each data point as a separate cluster. Now the second step is here the algorithm that merge the two data point, okay, based on the distance. So whichever the data point has the minimum distance, the algorithm that merge the two clusters, and it go long until all the clusters are merged into one big cluster that contain all the data points. Clear? So let's say here, let's say this one is first data point, second, third, fourth, fifth, and sixth. So here, let's say for example, first and second, in between the first and second data point, the distance between this first and second compared to first and third, first and fourth, first and fifth, and first and sixth. So compared to all the distance, so first and second, this has, let's say, minimum distance. So the algorithm that will merge these two data points in a one cluster. In the initial step, this one is a itself alone is a individual cluster. Cluster this one and cluster this two. Individual cluster. Okay. Now thereafter, after this C1, that is cluster C1, now the algorithm again that it will see the distance between, let's say for example, in between third and fourth data point, the distance is minimum. So it will again this merge third and fourth in a one cluster. Correct? Then next again, let's say for example, fifth and sixth. So again it will make one cluster. So this one is a C2, this one is a C3. Then again it will again search, okay, and see if there is a distance between the C2 and C3, that is distance between C2 and C3 is less as compared to C1 and C2. So this C2 and C3 that again that will make one cluster. And this C1 and let's say this one is a C4. So C1 and C4 that finally that will be one cluster. That is C5. Clear? So now the best part of this hierarchical agglomerative hierarchical clustering, all this merging of this data point, the algorithm that always remember the this data point. Okay. So first he merged the data point first and second, then he merged the data point third and fourth, then he merged the data point fifth and sixth, then he merged the data point C2 and C3. So likewise. So let's say for example, first, second, third, fourth, fifth, and sixth. These are my data points. These are the number of my data point. Okay. So now first and second, okay, the algorithm that merge the two data point in a one cluster, then third and fourth, okay, fine, fifth and sixth, then fine, then three and means three and four this cluster, and fifth and sixth this cluster, then again that it merge in a single one, then again that it merge in a single one. Okay, so like this. So this kind of representation that we call as a dendrogram, that we call as a dendrogram. So dendrogram is, it's a tree-like structure. It's a tree-like structure. Okay, that we call as a dendrogram. Clear? So at the last, there will be a single cluster. So here like C5. So this C5 that contains all the data files. That is the last big cluster. That is last big cluster. The exact reverse of this agglomerative is divisive clustering technique. So this divisive clustering technique is a top-down approach. Okay. So here in the divisive clustering technique, that is the second one. This one is a top-down approach. That is a top-down approach. So here the initial step is so let's say this one is my data point. Okay. See this first, second, third, fourth, and fifth and sixth. So begin with all the data point that is in a single cluster. This one is a single cluster. That is a very big one. Okay, that is the initial step. So in an initial step, we assume there is a one cluster, and in one cluster, all the data points that exist in a bigger one. Now, the second step, the algorithm that split this big cluster into two parts. Okay, then based on the distance. Okay, based on the distance. So let's say this one is a one cluster and this one is a one cluster. So now this bigger one that is split into the two clusters C1 and C2. Now we enter into this C2, then again it will split into a two cluster. Okay, so like here this one and this one. Then we enter into this cluster. Okay, then again this cluster and this one. Then we enter into this one. Then this cluster and this cluster. Means first we enter into a bigger one, split this into a two cluster. Okay, like this one and this one. Then we enter into this one and split this into a two cluster like this one. Then we enter into this one, then split this cluster into a two cluster like this one. Then we enter into this. Again we split into a two cluster. Then we enter into this. Then we enter into this. Then we enter into this. Okay. So this one is a top-down splitting. Okay. So this has means this is less common compared to this agglomerative clustering. Okay. The reason is computationally that is more expensive. Okay, because we have to apply extra effort in splitting of the cluster. So that is the reason that we use most of the time agglomerative hierarchical clustering. Clear? So up to so far, if you have any doubt, wait. So yes, participants.
Yes, sir.
Yes, is there any doubt from the participant side?
Uh, so, participants, if you have any doubts, you can write on the chat box.
Really sorry, I cannot see the chat box right now.
It's okay, sir. At the end of the session, maybe we can take up all the doubts.
Okay, okay,
Yes,
fair.
sir.
So now up to so far that we had discussed this agglomerative and divisive method. Okay. So now you can ask one question here. So how do we know the two data points are close to each other? So how do we do the clustering? Okay, so the point is the based on the distance. So based on the distance, meaning is, so distance we calculate here, that is the Euclidean distance or Manhattan distance. So based on this Euclidean distance, okay. So based on this Euclidean distance, that we will decide the which two data points that are close to each other. So if the two data points are close to each other, then the algorithm that will merge the two data point in a single cluster. Okay, so let me take one example. So let's say this one is a very small data set. 1, 2, 3, 4, 5, and 6. Okay, 6 data point. So P1, P2, P3, P4, P5, and P6, and P1, P2, P3, P4, P5, and P6. Okay, so now you see this P1 and P1, this one that will be equal to 0, the distance. So I am writing here this matrix in terms of the distance. So this P1 and P1, the distance between the distance of this itself is a point, data point is first, the itself, the distance itself is a data point that is 0. Okay, so now P1 to P2, P2 to P2 again 0, P3 to P3 0, P4 to P4 0, P5 0, and P6 that will be. So let's say in between the distance that is P1 to P2, so that is, let's say that's a 1. Let's say for example it's 2.8, 2.5, 2.8, 3, okay, 3.5, then it's a 1.2, this one 2, 2.3, this 1.5, 1 point, let's say 7, okay, then 5, 6, 2.6, 2.1, and 3.2, let's say. Clear? So these are the distance. Let me again just repeat this first one, that is the distance between the data point P1 and P2. 2.5, that is the distance between the data point P1 and P3. Likewise 2.8, the distance between the data point P2 and P3. Okay, now find the this close closest this cluster. So now identify the two cluster or the two data points that are close to each other based on this distance matrix. Okay, so now you tell me which one has the minimum distance. Now see this one, correct? So now P1 and P2, so P1 and P2, so this one has the minimum distance. So now combine this P1 and P2, this that will make a one cluster, okay, in a single cluster. So now this step reduce the total number of cluster by 1. At very first step, the cluster, that is how many number of cluster? 1, 2, 3, 4, 5, and 6. So total number of cluster, that is 6. Okay. Now here that is C1, P3, P4, P5, and P6. So total number of cluster that will be 5. Okay. So now in the next step, C1, P3, P4, P5, and P6. Okay. Here C1, P3, P4, P5, and P6. So C1 to C1, that is 0. C1 to P3. Okay. So C1 to P3. So P1 to P3 and P2 to P3. So now the point is Now you can ask here one question. The distance between the two data points, let's say this one is a 1 and this one is a third data point. Now the distance between these two data points, that is easy, Euclidean distance. So let's say this one is x1 y1 and here that is x2 and y2. Okay, so now Euclidean distance, that will be x2 minus my x1 square plus y2 minus my y1 square and root of this one, that is a Euclidean distance. Clear? Now the question is, how do we find the distance between the C1 and P3? This one, C1 and P3. So C1 that consists of two data points and P3 that is a one single data point, that is a one single cluster. This one is a one cluster, this one is a one cluster. Now question is, how do we find the distance between the C1 and this single cluster, that is a P3? So now in this case, see, this one is a C1 and this one is a single data point. So let's say this is P3. So now you have to find the distance between this 1 and 3 and 2 and 3. So 1 and this 2. So 1 and 3 and 2 and 3. Okay. So whichever has the minimum distance, that will be your final distance between C1 and P3. Okay. So let's say this one P1 to P3. So P1 to P3 2.5. Okay. And P2 to P3, this one is a 2.8. So the distance, so whichever is minimum, that will be your distance between C1 and P3. Clear? So now here, this, let me rub this one. So now C1 to P3. So C1 to P3, C1 to P3, that is 2.5. Now P3 to P3 0, C1 to P4, C1 to P4. Okay. So 1 to 4, 1 to 4 and 2 to 4. So 1 to 4 this one and 2 to 4 is this one. So which the minimum is, that is 3. Okay. So just you write down here, that is 3. Now P3 to P4, P3 to P4. So P3 to P4, that we know already, that is 1.2. Fine. P4 to P4 0. Now C1 to P5. Okay. C1 to P5. So 1 to 5, 2 to 5. So 1 to 5 and 2 to 5, which that the minimum is 2. So P3 and P4, P3 and sorry, P3, P5, P3, P5, that is 1.5. P4, P5, so P4, P5 is 1.7. Okay, and P5, P5, that is 0. Then C1, P6, so C1, P6. So 1 to 6 and 2 to 6. So 1 to 6 and 2 to 6, that is 5. P3 to P6, P3 to P6, 2.7 already calculated, 2.1 already calculated, 3.2 already calculated, and this one is 0. Clear? So now the next, the cluster matrix, that will be here. Before just going to the next step, just check whichever has the minimum distance, that will be your C2. So the minimum distance is this one. Okay. The minimum distance in here in this matrix, in this one, that is 1.2. That is P3, P4. So P3, P4, that will become one cluster, and you can call it here this is C2. Correct? So now the next matrix, here I'm writing here, this next matrix, that is C1, C2, P5 and P6. So C1, C2, P5 and P6. So C1 to C1 0, C2 to C2 0, C1 to C2, C1 to C2. So 1 3 1 4, 1 3 1 4, 2 3 and 2 4. So the minimum distance is 2.5. So this one is a 2.5. Now C1 to P5, C1 to P5. So C1 to P5, 1 to 5, 2 to 5. So 1 to 5, 2 to 5, that is 2 and 2.3. So that is 2, that is less. C1 to P6, C1 to P6 means 1 to 6, 2 to 6. 1 to 6, 2 to 6. So that is 5. Okay. Now C2 to P5, C2 to P5. So 3 to 5, 4 to 5. So 3 to 5 and 4 to 5. So 1.5 and 1.7. Okay. So 1.5. P5 to P5 0. Now C2 to P6, C2 to P6, 3 to 6, 4 to 6. So here this one 3 to 6, 4 to 6, 2.6, 2.1. So that is 2.1. Now P5 to P6, P5 to P6 already that we have calculated 3.2 and this one is 0. Now check which one is the minimum distance. So now the minimum distance is here 1.5. So 1.5 that is C2 and P5. So C2 and P5. So this will be your next cluster, is C3. Okay. So now the cluster after this, that is C1, C3 and P6. C1, C3 and P6. Okay. So just wait here. C1, C3 and P6. So C1, C3 and P6. So C1 to C1 0, C3 to C3 0, P6 to P6 0. Now C1 to C3, C1 to C3. So C1 to C3. So this one is a C3. So 1 to 3, 1 to 5. Okay, 1 to 4, 2 to 3, 2 to 4, 2 to 5. Okay. So now the next one is 1 to 3 here, 1 to 3, 1 to 5, 1 to 5, then 1 to 4, then 1 to 4, then 2 to 3, 2 to 3, then 2 to 4, and 2 to 5. So now you check which has the minimum distance. So the distance, minimum distance is 2. So this will be your 2. Now C1 to P6. Okay. So C1 to P6 that already that calculated, that is 5. Now C3 to P6, C3 to P6. So 3 to 6, 5 to 6, 4 to 6. Okay. So 3 to 6, this one 3 to 6, 5 to 6, this one is a 5 to 6, 4 to 6. So this one 4 and this one 5. Okay. Now check the minimum. Minimum value is 2.1. So this will be your 2.1. Okay. Now just check the minimum distance. This one is the minimum distance, means C1 and C3. C1 and C3. So C1 and C3. So that will be one cluster. That is C4. So now at the last, so now see here, the last one is that is C4 and P6. C4 and P6. So C4, C4 0, P6, P6 0. Now C4 to P6. Okay, C4 to P6. So now 1 to 6, 3 to 6, 1 to 6, okay, 2 to 6. So now the minimum value is here, that is 2.1. Okay, so now at the last, so this will be one cluster, that is C5. This C5. Clear? So now we have to update the distance matrix every time. Okay, so we calculate the distance between the new cluster and all the this existing cluster. Correct? So now here again you may ask one question, how to calculate the distance between the 2 point and cluster. Okay, so now this one is the cluster C, and this one, I think this one that we already uh, discussed. So this one, let's say this one is a P3, okay, and this one is a P1, and this one is a P2. So now just find the distance, okay, and let's say this one here, that is C1 and C2. So in C2, two data point P3 and P4, C1 two data point P1 and P2. So now find out the distance between P1 and P4, P2 and P4, P2, P3, P1, P3. So whichever has the minimum distance, so that will be your final distance between C1, C2. Clear? So based on, so now the question is, do we have only the one minimum this distance? Okay. So now the answer is we have the four linkage methods. Okay, there is a linkage criteria. There is a linkage method, linkage criteria. So the one method is min. Min is very easy, as we already discussed the minimum distance. So just check the distance between the two data points. Okay, so whichever is the minimum, whichever has the minimum value, that will be your final distance. So now the second linkage method is max. Third is average. Fourth is, that is what? Fourth is what? Okay. So min is easy, as the name suggests, maximum. So whichever is the maximum value, okay, maximum distance. So that will be your final distance. Average, the average of both the distance. Average of both the distance. So both the distance means, let's say this D1, D2, D3, and D4. Okay. So D1, D2, D3, D4. So let's say D1 is 5.6, D2 is 2.3, D3 is 4.2, and D4 is, let's say, 5.6, 5.9. So now the average is just 5.6 plus 2.3 plus 4.2 plus 5.9 and divided by 4. Okay. So now the word that we will discuss later, this word linkage method. Clear? So now finally that we have the dendrogram. So dendrogram like this one P1, P2, P3, P4, P5, and P6. So P1, P2. So according to the this P1, P2, P3, P4. P1, P2, P3, P4. Then one more cluster. Then this one cluster. Then this one cluster. Okay. So this is our dendrogram. This is our dendrogram. Clear? So now here this x-axis, that is the data point, number of the data points. So here in our example, 6 data points are there. So P1, P2, P3, P4, P5, P6, and that y-axis, that is the inter-cluster distance. That is the inter-cluster distance. So here inter-cluster distance meaning is, see, this P1 and P2, that is the cluster number 1. Okay. Now this P3 and P4, that is cluster this C2, this distance. So I'm saying the distance. So this one is the inter-cluster distance. So now this one. Okay. Then again that is this one. Then again this one. That is the distance. So intercluster. Clear? Okay. So now the point is where we use this hierarchical clustering technique. So hierarchical clustering, this technique, this algorithm that we use here, this in data mining. That we use in data mining. So what is the data mining? So data mining is a technique, okay, in which for data analysis we use the machine learning technique. Okay, so sometimes for data analysis, uh, most of the time for data analysis we never use the machine learning, but if we use the machine learning technique in a data analysis means that is through chart. Okay, we analyze the data through the chart, through the graph, through the box plot, through the bar chart, through the histogram. Okay, so if we use the machine learning, in this data analysis, okay, so that is the data mining. Most of the time that we never use the this machine learning here in the data analysis, but if we use the machine learning in this data analysis, that is a data mining. Okay, so the second that is application is that is customer segmentation, where we want to apply the better marketing strategy. Okay, this customer segmentation, customer segmentation. So let us say, for example, in Mintra, the let's say in the next month the big sale that will come. Okay, so we will message not all the customer. Okay, so the big sale that will come, so that we will not send a message to all the customer. So why we should spend the extra money to send the message to all the people? So here customer segmentation that is useful. So that is first that we segregate the customer in a way of male and female. Okay. Then in a male, the salary that is more than 10 lakh. Okay. That salary that is less than 10 lakh. Okay. Then if the person having the salary more than 10 lakh, the again just check purchase less clothes in last year or purchase more clothes. Okay. So K means that will not do this hierarchical clustering. Okay. So here this one is the segmentation, customer segmentation. Clear? So now again the question is what is the optimum number of clusters? The question is what is the optimum number of clusters? So optimum number is, so in the previous this one dendrogram, so this is the intercluster distance. This one is the intercluster distance. Okay. So first you just find the largest vertical line. The step is just find the largest vertical line. Largest vertical line that should not cut by any horizontal line. So this one is a horizontal line, this one is horizontal line, this one is again horizontal line, this one is again horizontal line. Okay, this one is a horizontal line. So now check the largest vertical line. the vertical line that which should not cut by the horizontal line. Okay. So this distance, this one, this shows the distance between the two clusters. Okay, distance between the two clusters. So now this one is the intercluster distance. This one is the distance between these two clusters, P3 and P4. This one is the distance between the two cluster in between C2 and P5. So this one that has the distance between the cluster C2 and P5. So this one that has the distance, this one is the distance between this uh, C1 and C2. Okay, C1 and C2 is this one. This one is, let's say this one is a C3. So C3 and P6. Okay, so first you have to check the largest vertical line. Okay, so now let's say this one is the largest vertical line. Let's say, for example, this one is the largest vertical line. This vertical line that shows the distance between the two clusters. Distance between the two clusters. Okay, so this one is the largest vertical line. So now this largest vertical line, now you draw one dummy line. Now you draw one horizontal dummy line. Okay, so horizontal dummy line. So now it cut this vertical, this vertical line. Okay, means this horizontal line that cut the vertical line at 3 points here, here, and here. Okay, so the optimal value that will be 3. Optimal value of the cluster that will be 3. Clear? This one is a very subjective method. So after 5 to 10 minutes that we will discuss in detail this one. But now this one is a very subjective method. First you check the vertical line and just you draw one dummy horizontal line and just check the intersection point. So here this one is the intersection, this one is the intersection, this one is the intersection point. So the optimal value of the cluster that will be 3. Okay. So now question is dendrogram depends on the features? It's a dendrogram that depends on the feature, yes or no? If we have suppose 5 input feature, or if we have suppose 10 input feature, so is this dendrogram that depends upon the number of input features? So the answer of this question that we will discuss at the last. Okay, so now here the point is next, in which case we apply which one of the linkage criteria. So we have the 4 linkage criteria: min, max, average, and what. So now question is, in which case we apply which one of the linkage criteria. So actually the linkage is the criteria that determine the distance between sets of observation. The sets of observation that is as a function of the pairwise distance between the observation. So there are kind of several this method, and each defining the distance between the clusters differently. Okay, so now first let us check this min linkage method. Okay, so min linkage method. So let me explain in detail. So min linkage method. Okay, so the distance between the two clusters that is defined as the shortest distance from any member of one cluster. Okay, to this any member of another cluster. That is the linkage, minimum linkage method. Okay. So now the speciality of this minimum linkage method. So this minimum linkage method is capable of detecting non-elliptical shape. Okay, that is a specialty. So now the example here, see this one. Okay, so now according to K means, so this will be one cluster and this will be another cluster, C1 and C2, according to K means. But here in the hierarchical clustering, so this will be your one cluster and this will be your second cluster. Correct? So now second point is that this agglomerative that works very well for the data set where the clusters are well separated. Okay. If clusters are well separated, then this hierarchical agglomerative clustering is the best clustering algorithm. Disadvantage. Okay. So now the point is here that work that very well for data set if or where the clusters are well separated. Okay. Now the disadvantage. So this one is an advantage. Okay. Now disadvantage. The disadvantage is that it may not perform well when the clusters are close together or overlap, as it is sensitive to outlier. So this may not perform very well when the clusters are close to each other. This minimum linkage method. Clear? So now the next is max linkage. So max linkage, or that is a farthest point algorithm. So here the advantage is if the means simple, if the distance between the two data points are maximum, then that will be your final distance between the two data points. Let's say, for example, this one is a one cluster and this one is a another cluster. This one is C1, C2. Okay, so according to this max linkage method, so first you have to find the distance between this P, let's say this one, 2, 3, and 4. So first and third, first and fourth, two and third, and two and fourth. So whichever has the maximum one, so that will be your maximum linkage method. Okay. So the advantage is that is a less susceptible to noise or outlier. That is less susceptible to noise or outlier. Clear? So this one is a max linkage criteria. That is the advantage. And the point is the problem with this maximum linkage method. So this method that struggle with elongated cluster or non-convex shape. Non-convex shape means so like this one, this one. Okay. So non-convex means, and one more this one. Non-convex shape means one is big and another is small one. Okay. So that is the disadvantage with this max linkage method. Now the third is, okay, so now point is, if you have the outlier, then better to use this max linkage. You have the outlier, so better to use max. And if you have uneven cluster, okay, one big and one small, so that is one big and one small, then better to use this min. Okay, so now third method is, that is the average linkage. So average linkage means, just it's very simple. Just check the distance d1 plus d2 plus d3 divided by 3. Okay. If one more distance is having d1, d2, d3, d4, then divide by 4. Likewise, 5 distance, so divide by 5. So that is the average. Okay. So now come to the most important linkage method is WARD. Okay. So now WARD method, the specialty of this WARD method is, this one is a default method. This one is a default method in sklearn library. Okay. The principle of this WARD method is, that is a variance reduction. Principle of this is, that is a variance reduction. Okay. So variance reduction means what is the mathematics behind this WARD linkage method? So the point is, let's say we have the two clusters, this one and this one. Okay, so we assume first that these two clusters together make a big cluster. So now this one and this one. Okay, fine. And we will calculate here the centroid of this big cluster. Centroid of this big cluster. Okay. And then you check the WCSS. So this WCSS is within the class sum of square. That is one parameter that is within the class sum of square. Okay. So now here centroid, first we check the centroid. Let's say this one is a centroid C. Now this D1, D2, D3 and D4. So D1, D2, D3 and D4. Okay. So now here we square them and add like D1 square plus D2 square plus D3 square and plus D4 square. Okay. So first you find out the centroid. Okay. Then after, just you check the WCSS. Okay. So now you forget this big cluster, this one. Now you forget about this big cluster. Okay. So now again that we will calculate the centroid in these two clusters. So now centroid of here, that is C1 and C2. Centroid of C1 is, let's say, here. Centroid of this C2, let's say, here. So now again the final distance. So that is d1 square plus d2 square, d3 square plus d4 square minus c1 square minus c2 square. So c1, that is, this one is c1 and this one is c2. c1 and c2. Okay, and here this one is the a1, this one is the a2. So now minus a1 square minus a2 square. So this one is the WCSS, that is a big cluster. WCSS of big cluster. Then this one, that is the WCSS of this C1. Okay, so WCSS of 1, and this one is WCSS 2. So this one is the big, this left hand side, and this one is the right hand side. Okay, so the point is, this is the gain in variance. Which one? This one. This is the gain in variance. So if this number is large, means we have clustered in separated form. If this number is less, then we have cluster in shrinkable form. This one is a very important point. So let me repeat one more time. So this one is a gain in gain in variance. Gain in variance. Okay. So if this gain in variance means, that is WCSS. Okay. WCSS means within the class sum of squared. So if this WCSS, if this number is large, this number is very large, so we have cluster in separated form. If this number, that is very less, okay, in this case the cluster is, that is in shrinkable form. That is, data points are very near to each other. Okay, so we expect the minimum value from this final distance, from this final distance. Clear? So we will select those clusters which have minimum ward linkage. So that is, variance gain is very low. So after making a cluster, there is a no variance. So there will be no variance. Correct? So first, that is minimum. So the minimum, this WCSS. So you have to check the this minimum value. So this one is the ward method. This one is the ward method. Correct? So now, in continuation of this, so there is a time complexity, okay, and space complexity of this hierarchical clustering, agglomerative hierarchical clustering. So time complexity and space complexity. So first, let us check this space complexity. So if any algorithm run on the data set, so how much the RAM that will use, that is a space complexity. Okay, so space complexity of this hierarchical agglomerative method is n space. Because here the n number of data points, here the n, that is the reason of square is here n, that is the number of data points. So we calculated the distance from one data point to all the data points. Okay, so n number of data points. and then we calculated the distance. Let's say this is a simple that example that we took initially. So 1, 2, 3, 4, 5, and 6. So that is the distance, that is n cross n minus m1. Okay, so self distance that we have not calculated, so it's almost near about equal to, that is n square. Okay, so now the next time, that is n minus m1 cross n minus m2. Next time, that is n minus m2 cross n minus m3. Okay, so but at one time initially that we have calculated the n square distance. Initially that we have calculated the n square distance, and this n square distance, that, as I said, this agglomerative hierarchical clustering, that it keep all the track record. Okay, so that it store in a memory, so its space complexity is n square. The problem is, if suppose we have a big data set, so big data set, let's say that is data set that contains the 10 lakh data point. Okay, so distance, that distance value, that is 10 to the power 6. Okay, 10 to the power 6. So the value to be stored in RAM is near about 10 to the power 12. Okay, so 10 to the power 12, so this would be in GB. So we cannot apply this data set on this 8 GB or this 16 GB RAM. So this point is, so this important note, so this this algorithm is not suitable for big data, for big data set. Okay, and this one is suitable for the small, and you can say that medium data set. Now the next one is the time complexity. So the time complexity here, what is the time complexity? So let me explain the few basic points of this time complexity. So if we double the data point, okay. So initially let's say 100 row. Okay, initially let's take 100 rows, and it takes, let's say, 10 seconds. Okay, 10 seconds to apply an algorithm. So now if we double the data point, okay, how much time it takes to compile the output? That is the time complexity. If we double the data point, let's say 200 rows, then how much time it takes to compile this data or compile the output? That is the time complexity. So initially that we assume all the data points as a separate cluster, that is n data points. That is the n data points. So every time one data point, that will be minus from n. Okay. So see here example. These are the 6 data points. So now next time that 5 data point that will remain. The third step, that 4 data point that will remain. So likewise, okay. So every time that one data point, that will be minus that from n. Okay. So actually this is not exactly n square, but less than equal to n square. Less than equal to n square. Okay. And we are doing here n times n square calculation. So time complexity, that will be this. Or this order of n square log of n. Okay. So now space complexity is this one, time complexity is this one. Okay. So this time complexity and this space complexity. So this is the biggest drawback of hierarchical clustering. So that is the reason to this algorithm is not suitable for big data set. Okay. So now advantage. So advantage is it keep track record of the hierarchy along with this clustering. So other algorithm that does not provide such information. Clear? So that is the specialty of this hierarchical agglomerative clustering technique. So now next that this, uh, I will show one code of this uh, dendrogram, this agglomerative hierarchical clustering. So now see it. Open. Okay. So now here I took one data set of this country. Okay, country data set. That is a country. So that is near about more than 150 countries are there here. This export, this health, okay, this income, inflation, okay. So there are number of 10 number of input features. So let me just run this one. So now here I took the column, this only two column, okay, and the value, this one, okay. So now here, so scipy dot cluster, here the one, this keyword that is SHC, okay. So this SHC that is a hierarchical clustering. So here that I use this function, okay, SHC dot linkage. Here I pass all this data set and the method that is a word. So you can change here that is min, max, average. Okay. So here the by default that is a word. Okay. So you can change this linkage method. Okay. And the function is fsc dot dendrogram. So if you run this one, see this one is the customer this dendrogram. So the bottom one that is a more crowded just because of the 167 number of country. Okay, this 167 that number of the data point because it consider initially the as a single cluster of in each and every data point that it consider as a single cluster. So that is the reason to bottom side that is more crowded because it consider as a single one cluster as a one country. Okay, so the next one that is this cluster. Now here this linkage is what, so just you can make here 3 cluster or you can make let's say this 4. So let me run this one, label this one. Okay, so now this 0 1 0 1 0 1 is that is 0, that is first data point, that is in the cluster number 0. Okay, second data point, that is also, that is cluster number 0. So this third data point, that is the cluster number 1. So likewise, so there are 4 clusters, 0, 1, 2 and 3. So the first and second data point that are coming in the cluster number 0, third data point that are coming under this cluster number 1. So next two data point, that is again, that is coming, that is cluster number 0. Okay, likewise. Clear? So now this one is the visualization. Now you see, so 1, 2, 3 and 4. Okay, so these are the kind of the outliers. So let's say this one is 3. Let's say, for example, that is 3 number of cluster. So 1, 2, these are the outliers. Okay. So these are the outliers. Okay. Now it is not. Yes. 1, 2 and 3. Red, this blue, and this one is green. So there are 3 clusters. See this one. Clear? So now the next, this advantage and the disadvantage. So now advantage, the disadvantages of this hierarchical agglomerative clustering is, that is computational. First disadvantage is computational, that is complexity. So that it makes impractical for the large data set. So we should not apply this hierarchical clustering if we have the big data. Okay, so that is a one disadvantage of this hierarchical clustering. Now second is, it's difficult in identifying the optimal number of clusters. Okay, so here at the time of this theory that we had discussed, the optimal number of the cluster. Okay, so optimal number, first we have to find the vertical, longest vertical line. The longest vertical line that should not cut by the horizontal line. Okay, so the point is that method is very subjective. So while the dendrogram, so that it provide insight into the potential number of clusters. Okay, so there is often this subjectivity that involved in interpreting where to cut the dendrogram to define the cluster, where to cut this dendrogram, this by dummy horizontal line. Okay, so now the number of intersection point, that will be your optimal number of clusters. So the disadvantage is that is very difficult in identifying the optimal number of clusters. So now the third is this arbitrary decision in linkage criteria. So the choice of linkage criteria, so we have the 4 choice of linkage criteria. That is, first one, that is a mean. Okay, second, that is a max, and third, that is average, and fourth one, that is a word. So this linkage criteria that can significantly affect the result, and there is no definite rule for choosing the best method which can make the process is arbitrary. So there is an arbitrary decision in linkage criteria. So that is a one problem in this hierarchical clustering. Okay, and the last one disadvantage is there is no global objective function. Okay, so there is no objective function. So in the objective function, we have to minimize the objective function. Okay, but here there is no global objective function is there. Okay, so we cannot improve. We cannot improve. And advantage is it keeps the record of all the merging this data point. Okay, and the second advantage is useful for any distance measure. The method that can be used with any distance measure which is beneficial for different type of data. Clear? And the third advantage is that it does not assume the clusters as spherical. So unlike K means this agglomerative clustering that does not assume that clusters are spherical in shape. So that can result in more natural cluster shape. Clear? So that is the specialty of this hierarchical clustering, this advantage and disadvantage that we had discussed. Okay, so now the theory part that is over from my side. So now if you have any question, any doubt, then we can discuss.